Right, so I've got the reference PCB apart again, and I've got it up in my extender card here. Now over here is a plus 15 volts rail, and there's the minus 15 volt rail. I'm getting plus 15, I'm not getting minus 15. And so I've got an issue either on this board, which is dragging it down, or the rail's just not existing, so I need to double check that. And over here, this, try and get you can see it, this regulator right here, or that device right there, is getting really hot. So I'm thinking there's probably a fault over here which is shorting out and dragging the supply down. Right, so I unplugged the card and I just probed on the extender card itself. You have to be careful because it's potentially 300 volts or so on this thing, so you have to be careful what you touch. But I can get the plus 15 volt rail on here, but not the minus 15 volt rail, which should be on pin 1 relative to pin 6 for the 0 volt. So yeah, it's the minus 15 volt was missing. I need to go looking. Something's still not right. Well, this is a bit irritating. I was trying to chase this negative 15 volt rail that's missing, and I noticed that this comes back to this power supply section just in here, which I've already verified is working correctly. I've already tested all that, and that is strange. So I tested it, and 5 volt rail was dead, and the minus 15 volt rail was dead on the card. I thought, well, that's odd. They were working before. I thought, what's changed? So I unplugged the riser card, and they came back. So it looks like the riser card may have a fault. Maybe it's not quite lining up on the pins properly or something. So that's a bit of a pain. Makes it I can't really test things very easily. Because I was trying to determine whether or not I've got the 10 megahertz oscillator on this board here. Which you'll currently see on top. Because there's a test point just here for the 10 megahertz oscillator. So you've got to try and get into it. So I might have to sort of tack a wire on or something to get to that test point. I'm not quite sure I'm going to manage it yet, but anyway, because once I know if the 10 megahertz is working, I can know whether this logic here is kind of doing something or not. So yeah, we'll see. I still need to test why that one is getting hot too. That's interesting. Right, so I've got this board here, which is the oscillator control assembly. I'm just going through testing all the parts, and I've checked all the semiconductors and they all seem fine. I'm doing capacitors. I can't obviously check ICs, that's just based on function. I can't test those as such. But all the other parts seem fine. I can't find any other faults on the board. Now I'm checking capacitors, and what I've found is I've got some 6.8 UFs there and there, and these are 22 UFs here. So the 22s measuring 100 Hertz this time because of smaller capacitors. Yeah, 1.3 ohms. Yeah, that's kind of alright, I suppose. You know, for the voltages, they're quite low voltage ones. Forgot to see what it was. 22 as well. These ones are all looking pretty much exactly the same. All right, they all look fine. This one's slightly higher, but not much. So they're probably okay. These are what are these rated at? I'm trying to see. 15 volt DC, right? So the low voltage ones, so the resistances on low voltage ones do tend to be a bit higher anyway. So over here is 22. Oh, sorry, 6.8. That's reaching 33 ohms, which is quite high indeed. And then over here, 74 ohms and 17 UF. And that one there, 80 ohms and 9.7 UF. Alright, so those two there are no good. This one here is on the way out. As far as these paper caps go, I'm not really sure about these. I'm getting some nonsense readings from them, so I don't know if it's just the way this meter works for those capacitors. I'm getting a reading from that one, which actually looks about right. Actually, that one measures okay. This one here, no, nonsense reading. Measure this one here. Yeah, maybe. That's a 0.15 MF, so try and get back on. So that's about right. That one's just given a sensible reading. If I do this one here, I want to try and get onto it. Yeah, I mean, look, 2PF, that ain't right. So I don't know if these capacitors here are actually stuffed. I mean, I'm getting nonsense readings on a lot of these paper ones. So maybe these are all no good. I need to replace them all, but that's supposed to be 0.33 MF, and this is 442, so it's pretty close. So I mean, I don't know. I'm a bit torn between that. Perhaps someone can give me some advice on that, because it's not something I normally do. These aren't the kind of capacitors I'd normally mess with. So, but I do know that they can fail. 0.068 that one's supposed to be. It's 442. Same as that. I'm thinking parallel. They're exactly the same readings. Very close to it. They might be in parallel. Yeah, so I'm just a bit unsure about what to do about these ones, because say some of them measure correctly, some are just really wacky. I mean, that's just like 14 NF, 40 ohms. I mean, what is that one? It's supposed to be a 0.013, so that's actually pretty close. It's supposed to be a 0.013 as well, and that reads nonsense. So I'm not sure if it's because of some of these capacitors connected to, or whether these are actually faulty. So I'm suspecting there may be a fault with them. I might just have to lift one end and retest in case it's circuitry. But yeah, I mean, I should probably replace them. But yeah, I don't know. What's this cap here doing? Haven't looked at this one. Yeah, I don't know. 58 NF, 59. What's it marked as? 0.01? No, I don't know. No idea. Yeah, so anyway, I've got these electrolytics I'm going to replace. Now, what I've got is I've got these ones here. Now, I don't have any 6.8 UF. These are 10 UF. I also have 4.7. I don't have any 6.8, and I don't seem to be able to find them either. I don't know what the hell story is there, but anyway. So I've got these ones, and you can see these also measure about 3.2 ohms. Right, so these measure a little bit higher because of the voltage. This is a 63 volt one, so the 4.7s measure about 12 ohms, and these are Vichets. Right, these are good quality ones. Although these are only rated 85 degrees. It seems like these axial ones are only rated for 85, which is quite interesting. So I'm going to replace these 6.8s with these 10s. Those are the power supply, so that I'm comfortable with that. This one here I need to probably look at a little bit. It might affect the circuitry, so I might have to consider how I do that one. It may be a mistake to do it that way. I might have to put like two 3.3s together, couldn't I? Two 3.3 UFs in parallel or something. That's also possible, but yeah, electronics, isn't it fun? And the other thing is, now I've taken the back board off this thing. This is a board which I identified early on as someone having messed with it. Okay, so there's the obvious marks like the cut track here, which has been resoldered, and over here also cut and resoldered. And a few parts would like being resoldered, and these changed. And there's a scrape marks through here between the pin connections where these have been resoldered. So there's, obviously someone's been working on this board trying to diagnose a problem. And that's interesting. There's a jumper bridge between those two pins on that device there. What is this meant to be there? Looks like it's been added in. It's not like a leg has been bent over. So that's interesting in itself. Anyway, yeah, so I've got some suspicions about this board as well. In fact, that someone's been working on it. I mean, this chip looks like it's been resoldered. And is that? Just looks like there's an odd bit right there next to that pad. It might just be nothing, but this chip here has been resoldered. So someone's been working on it at some point. This one actually looks like it's been replaced because these pins are sticking straight out. These are bent over. Those are sticking straight out though, but these are longer. So that's been replaced. This one's also been replaced, as is this one. And maybe that one too. These are longer and sticking out. So I don't know, it's a... can't say for sure actually, they're all a little bit different. See where a lot of G chips have been replaced. It could well be that these, that one, that one, that one, that one, this one, and that one have been replaced because all those legs are sticking out more compared to a couple of these, like that one is much lower and bent out, as is that one, that one, that one. So could be a whole bunch of these chips have been replaced. So I don't even know if this board's got a fault on it. I've got no idea. All I'm doing right now is going around and testing stuff. There's a bad solder joint right there on that leg. So I'm just going to test stuff and replace anything I think looks a little bit dodgy and see how we go from there. But I can see that, you know, there's potentially a part missing here. I have to look at the circuit diagrams, and I'll probably resolder some of these again as well. They just don't look like they're great. Not like, it doesn't look like they're soldered very well. So I do little things like that, touch-ups. Alright, so I'm looking at the data sheet for this LM710 device. This is a voltage comparator apparently, and this is what's in that U1. Is it U1? U7 location, sorry, U7, which has got a little jumper on the back on the trace side, well, on the bottom of the board, between two pins, which looks factory. And sure enough, it looks like it is. It appears to be a mistake on the board. Now, that jumper's between pin 7 and pin 6. And as you can see here in the data sheet, pin 6 doesn't do anything. Pin 7's the output. Now, if you look on the board, pin 7 has no traces going to it. Pin 6 does. So it looks like they've incorrectly routed the traces, or they've changed the device or something. And so that's what the link's on there for. So the output is then going to the correct trace. So if you ever see that on your board, then it's not a problem. It's meant to be there. It's fine. Right. So this is the back of this board here, which is the attenuator assembly, which is quite meaty, and I was looking really closely at it. I've done all the tests on the other side and everything seems to be okay as far as semiconductors go. You know, transistors and diodes and stuff look okay. So, well, I don't see anything. I think it wasn't any transistors actually, but diodes. There's a solder joint just there which doesn't actually look like it's soldered properly. There's like a leg of a, is that a transistor? No, relay. There's a leg of a relay there, and it's not really soldered. There's almost no solder at all on this side, and there's one over here which is also really badly soldered. And I think I did see there's one there which is a bit dodgy, and I did see some more. I think there's one over here as well. So I'm just going to go over this board and resolder a few joints on it, and we'll see if they change anything. I mean, I don't even know if this board's got any faults. I can't tell yet. We're just doing that to check over every single board, every little thing I can test manually, and as I've been doing for these other ones, and then I'll go back to actually doing diagnostic troubleshooting. So anyway, let's just resolder these bits. And any other bit I can find which doesn't look right. Where's the other one? I've lost it. Now I've got a solder on my hand, I can't find them. I know there's more. I know there's one over here somewhere. I've lost it. Can't see where it's gone. It's a bit dodgy. Yeah, anyway, we'll see how we go. Right, so I'm working through this, trying to figure out what is wrong with this bloody unit. I know I've got the power supply working correctly now. Power supply works correctly, the reference supply to the power supply works correctly, so I'm getting there. So I thought, well, I'll work on this overload issue next, and I haven't found anything yet. Part of the troubleshooting information in the manual says to check this card here, so that's what I'm doing. But I'm a bit of a loss, really. I mean, it said to check some various voltages around the place, and Q7 and Q8 I think it was, which is this Q7, this Q8, they had some different voltages on them. And TP7, which is over here, just off screen I think. Hold on, let's just move this up a little bit. Right, TP7 just over here, that is way out. So yeah, it's found the voltage just checked, looked okay. So I thought, well, okay, I'll just poke around, and actually 14 is very hot. Well, it gets quite hot, shall I say. And also these resistors here, which gets quite hot too. I need to check here actually, because there's some signs of heat here. These feed this IC here, U10. Now this is an SG3501AN, which is a dual rail 15 volt power supply. So it's got some Zeners here, which drop the voltage down to 20 volts, or 18 volts, sorry, going into the IC, and then is that right? No, 20 volts here, that's right, 20 volts to the IC, which then drops it down to 15 volt dual rail, which then runs some other stuff which feeds those transistors over here. So that's why I was checking that, but U10 checks that okay. U14 runs hot, which is interesting because it's not running anything right now. Right? It goes to, I think it's this connector here it goes to, yeah. I think it's that one. And I haven't got any of the outputs plugged in. So this op amp here is driving nothing, but it's getting warm. So I'm a bit suspicious about this unit here being blown. I've checked the power supply inputs on it and they all seem to be okay. They're plus or minus 18 volt rails on this device here. So yeah, I've only just really started digging into this particular board, but I just want to check everything on each board. I mean, as you've seen previously, I've gone through and tested individual components, but that is no guarantee. I mean, I replaced these capacitors over here, for example, right, and this one over here as well replaced. So there's a few bits and pieces I've done, but so now I'm working through what is in the manual saying troubleshoot, you know, to do some voltage checks, just to try and pin down what may or may not be wrong. So TP7 is wrong and Q7, Q8 are wrong. I need to figure out why. I haven't dug much further than that yet. There are some other parts I can do voltage checks on, but I haven't done those yet. But Q7, Q8 seem to be a bit of a clue. Yeah, they're sort of floating a little bit. There's a TP5 here, which has got this adjustment. Now I did this calibration from the manual on that TP5. I noticed as I was adjusting it, sometimes it'd be absolutely fine, you could adjust it bang on, and then suddenly it'll jump out, and then it'll be drifting, and you couldn't get it into spec. So I think there's some kind of signal feeding this board which is being wacky. It's dropping out and coming back, I think. When it's working, I calibrated, so it's supposed to give you like a null reading or something on minus test points. I can't remember. I think it might be 7 or 1. No, it's 5. Yeah, of course, it's 5. Yeah. Anyway, so yeah. To be honest, I'm getting really tired of this unit. It's taken me way too long to fix this, and time is not something I have a lot of right now. This is going to probably take me months to get this unit up and going again, I think, at the rate I'm going right now, because my time is split between doing this and getting ready for this big show we've got coming up in a couple of weeks' time. So, mind you, by the time you see this video, I probably would have done a show, but anyway. Yeah, so we'll just keep on plodding away. Right, so there's the circuit diagram for that board I was showing just now. Now the parts I was talking about are here, R104, R105, which are those resistors which I noticed getting hot. There's hot spots on the board you can see. Here's U10, which is that dual valve voltage regulator. Let's just make this a bit bigger for you can see it. So it's got plus and minus supplies coming in, which is done by these Zenas here, which is why it is getting hot, because it's 30 volt rail being dropped down to 20 volts. So it's dropping 10 volts across those things. And then you've got this regulator here, which then puts out positive negative rails of 15 volts. Now it says SG350, but it's actually SG3501AN, the actual part number. Now this part brings the rails over for this section here. Alright, that's what it's doing, is running this section. Now all this seems to be interrelated. This chip looks like it's been replaced because it's inside a socket. It's the only socketed part on that board. So I'm suspecting that's been replaced at some point by someone. This board, remember, has had parts replaced on it. Someone's been working on this board previously. Now the other resistors I noticed has got hotspots is actually R17 and R18. Right. So again, this is all coming back to this area of the circuit. And then Q7 and Q8, the voltage is a little bit odd on them, as per the test procedure in the manual. This states some voltages to check, and those don't make sense. So I'm wondering if one of these resistors maybe has gone open. I need to check those. But yeah, I've measured the cross CR15 here, which is 5.6 volt Zener. Let's make it a bit bigger for you in that section. Right, so ERC15, I've done that. That Zener measures okay. I'm getting 10 volts on the emitter of Q7. So I think that part is okay. But it says R17, R18 and R13 is the other resistor, but that's in a group. There's 3 resistors in side by side, 17, 18 and 13. 13's over here. That's a 1 mega ohm, so I don't think that's going to be getting hot. It'd be seriously wrong if something is, doing that. But so I think it's one of these two which has been getting hot. And as it's across Q8 here, right? So you got plus 15 volt that side, minus 15 volt that side. Right, so if this shorts out, you've got 30 volts across 3.6k. So maybe, right? And likewise here, you've got 10 volts that side because of the Zener. So you've got 25 volts across 5k. So potentially that could be why I was getting hot, because one of these transistors here are faulty. I did go around testing, so nothing obvious came out of it though. But yeah, who knows. And TP7 is over here, oscillator control input. So this one here is also giving me a different voltage from what was specified. It's on page, what page is it? Page 107. This is done in sections, which is a bit of a pain. Where is it? Is it here? No, much later than that. Page 107, bring it down. It's over here somewhere. Let's find it. I'll show you what I mean. Alright, 104, getting close. 107. So this is that section here which I'm talking about. I haven't done the DC to DC converter yet. I thought I'd start on the oscillator. Well, oscillator control assembly actually. So TP7 says minus 12 volts when I was getting plus 15, alright, or plus 13 or something like that. It wasn't negative, I was getting a positive, which makes no sense to any of these statements here. Emitter Q2 makes sense, Q3 made sense. I haven't measured CR78 yet. TP5, yeah, I did that calibration thing on there before, so that kind of works sometimes, not always. Sometimes I was getting this kind of level on it as though the oscillator wasn't working. So that's interesting. When I had noticed that fault before, I was getting to like around a volt, negative volt, right? So that might be a clue that the oscillator itself is playing up. Source of Q5, Q6, that was okay. Base of Q7, base of Q8, those didn't match. Specifically Q7 didn't match. I was getting about 10 volts there, so it's a bit different. Not hugely so, but a bit different. TP6 was completely wrong. I haven't measured these. So I've got some discrepancies just here, especially on the TP7 input here. So that makes me wonder a little bit about that. I haven't done any of these tests here yet, but I will be checking these shortly just to see if I can determine if any of these are wrong as well. So I might just go back and test this diode here, and then go through these ones here and just see what these come out like.